So I should say that the institute that I led in Washington, D.C. was actually an apolitical institute. It was not a partisan institute. And it was a think tank that's funded by the federal government in the U.S. to really provide continuity and support and research for the President's Science Advisor and the Office of Science and Technology Policy, which sort of encompasses then the National Science Foundation, the National Science Board, National Institutes of Health, all the different R&D agencies. And that's actually where a lot of my thinking for today's talk has come from, because during my time there, what do I need to do? Oh, it's still starting. All right, great, thanks. So during my time at the Institute, it gave me an opportunity to really crystallize some of my thinking about big data. And I'll tell you in a minute what I mean by big data. But even more importantly, it made me recognize that there's a collision that's in progress right now. We tend to think of big data frequently in the context of physical sciences and engineering. But in fact, today what we're seeing is a major collision of massive amounts of data with social and behavioral sciences. And so that's sort of my theme today in what I'm going to talk about, and the important implication that has on how we approach policy and policy decisions. Okay, so there we go. I need to acknowledge two collaborators on this, and we've actually written an article that's recently come out in a little publication called Significance. One is Stephanie Shipp, who is a colleague from the institute that I've just left, and then Steve Koonin, who is currently the new director of a center in New York called CUSP, the Center for Urban Science Programs. Anyway, it's a major urban observatory. I'll say more about that as we go along. Toronto, University of Toronto is a partner in this. Waterloo is not. But Singapore, some universities in the UK are all coming together for this new initiative in New York, as well as the city of New York being a big partner. Okay, what is big data? So it's all kinds of data and information. It's not just numbers. It's all sorts of information, text, other sorts of things that you can scrape, things that you can observe passively and actively. And I think it's fair to say, and I think this group probably understands, that every global challenge that we have today is rooted in information. And our decisions that we make on this should be evidence-based and should be driven by information. That's going to require integrating a lot of things. It's going to require integrating a lot of different fields of study. And it's also going to cause us to integrate a lot of heterogeneous types of information. Well, I'm a statistician, and so I was really happy to hear Hal Varian let me know that I'm in the sexiest career. And this actually came out of a really interesting report that was produced, well, actually an update to this report that was produced about a year ago from the McKinsey group. But he really does articulate what the situation is. And just last week, I'm being usurped by data scientists as being the sexiest of our jobs of the 21st century. But the point being, it isn't just the statistician, it isn't just the computer scientist. Data scientist is now being used as a term to encompass the broad swath of individuals that are going to use data and information to solve problems. And here is a very old quote that showed up in the Harvard Business Review, attributed to two different people, Deming and Drucker, that you can't manage what you don't measure. And that's really true, and that really plays into policy. Okay, so when we think about what data has been used to drive policy historically, and this is a very US-centric view in terms of the agencies that I represent, but I did get Statistics Canada up there. I think that the situation is very similar in Canada, that you have federal statistical enterprise that cuts across a lot of different agencies, plus you have other agencies like here we have NOAA, the US Geological Society, the Center for Disease Control. Those are there are Canadian versions of all of this, plus there's a lot of collaboration. But that has been typically kind of the official government data that has driven policy. Well, the world is changing vastly, and we can no longer sit back and assume that's all that's going to drive policy. And there have been, I don't know if you're familiar with the MIT Billion Prices Project. Folks familiar with that? Where students at MIT did incredible web scraping and ended up coming up with better predictions on prices in consumer price indices than what was coming out of Department of Commerce. Google did the same thing based on public data and on sales and things that they have. Again, this McKinsey report that has recently come out, and you know, ACM is always ahead of the times. Their tsunami issue actually came out about 4 years ago. So this is coming. This is coming, and it's colliding in the social and policy space quickly. So I've been preaching, literally, over the last couple years that we need to pay attention that this data revolution is colliding with social sciences. And we need to sit up and take notice of that. And it is going to be brought together for social policy, and the question is, who's going to do it? If we all sit back and ignore this, somebody else is going to do it. The Googles of the world are going to do this. And the question that you have to ask is, if you could know anything about society, what do you really want to know? And I like to ask social scientists this all the time. If you could take a slice through this mass of data, what would you want to know? And how would we figure it out? Now, typically social sciences data has been a tradition of surveys and experiments and more statistical data flows. And folks might argue with me, but I think for most of what we teach, that's true. But there are different flows of data right now that I like to call organic data flows that we should be paying attention to. So I have a thought exercise coming from physical sciences that I think really describes where I'd like us to get in this tsunami of data colliding with the social sciences. So I think we probably all know about the Sloan Digital Sky Survey. So this was done over a period of years to survey the entire sky, looking at the galaxies. And then all of that data was kept. It wasn't just tossed away, it was kept. And from that, scientists have spent years pulling spectra and ultimately doing things like finding where our supernovas are. And the most interesting thing about this data is that the vast number of users and the majority of the publications have come from people who have never looked at the sky through any kind of a telescope or device. So archiving, curating, and data reuse is critical. The amount of money that this has saved in the progression of science, you know, it has to be huge. I don't know if anyone's calculated that. But I'll tell you, their problem is easier than yours. We had a single instrument with certain types of filters and certain ways the data would be stored, archived, and used. So the astronomy community may be ahead, but their problem is easier than what you're trying to address today. Others are creating observatories. There is the NEON network, which is a network of continental scale ecological data collection and forecasting. Okay, so what about in the social space? What if you could fully instrument a city? So you have all your transit data coming in, you have all your public works data coming in, you could create passive sensing, and I'm going to show you some pictures in a second. What if you could actually create an urban observatory? What would be the data flows? How large would they be? What could you see? What could you do with it? There was a wonderful article, Society's Nervous System, Building Effective Government Energy and Public Health Systems, all about passive sensing in an urban environment. Okay, who just had that little tingly up the back of their neck about privacy? Well, I'm going to ask you to indulge me for a few slides. Let's just put privacy aside for a few minutes. It is an issue, big issue. Okay, what would the data flows be? And so here's kind of where the fun begins. So I should say that my collaborators, Stephanie Shipp is an economist and has worked in various roles throughout the US federal statistical system. And Steve Koonin is a physicist. You know, so he's an instrument guy. And Stephanie is somebody who worries a lot about social indicators. And I'm just a data wonk. So there we were. So we had some fun. What would you have? You could think about societal data, administrative record surveys, you know, transactional things, personnel things, operational things. But you could also think about physical things, in situ sensing. And by the way, all the technology exists. There's no new technology to be built here. It all exists, everything on this list. That's what physicists do, and they use it for all different sorts of reasons. There's a different way to consider that same set of data flow that might resonate better with some people, that you've got this organic data, things that are measuring location, and this is just a partial list, maybe political views, your health, other sorts of things. And then there's actually design data that governments spend a lot of money, researchers spend a lot of money, agencies spend a lot of money actually having this design data collected. So there's both of these types of data. And what I'm advocating is that it's time that we think about how these come together in ways that are going to help us learn things about our world. So what would you do with the data? And again, this is where I get very excited. You could do so many things with the data, not the least of which would be measuring, greenhouse gas emission treaties. It'd be kind of cool. You could understand differences in our city. You could understand differences across the city, things about law enforcement and security. There's just a whole host of things that you could do with this. And we've hosted a few workshops where we've brainstormed on what would be the things we would want to do with this. And how then would we put this together, and how do we get the researchers to begin to collaborate across the discipline sectors to actually do this? How would we collect it? So you're going to see Steve in this part of the talk here. Well, we would collect it just through the transactional data streams, scraping off the web. Do you know how good our students are in every field at building web scrapers? It's unbelievable. So let's take advantage of that. We're not quite as good about analyzing unstructured text. There's federal urban administrative data. I said the in situ sensing, traditional remote sensing, and then standoff sensing. And this is where we could have some urban vantage points, and I'll show you what those might look like. So here's just different types of technologies that are out there right now doing things. This is going to be the idea for our urban observatory, tall buildings. Okay, so this was kind of fun. How much data are we talking about? How much are you going to have to curate? What's it going to take? Well, I just got back from Dubai and from Delhi, so my 3 million is a little bit undersized. But nonetheless, in North America, suppose we've got 3 million people within a 10-kilometer radius in an urban area. There'll be about 1 million households and about 0.3 million businesses and 0.5 million, a half a million vehicles running around. So what does that turn into in terms of data rates? Now this is a back of the envelope calculation, so you can quibble, but I think it's probably not too far off. So you probably would be getting 20 bytes updated every 5 seconds, 12 megabytes. Transactional data is going to be a lot smaller, less frequently. And in the end, over a year, for these 3 million people, I might have 600 terabytes of data. In today's storage costs, actually in about 6 months ago storage costs, that's about 100K. It's probably much less than that today. It's not that much. It's just not that much. You can do this. All right. What if we wanted to truly do some passive sensing to go along with all the other kinds of data that flows in? And there's a lot of data that flow into these cities. You've heard of some of the smart city initiatives that IBM and others are putting up, and all the data flows and things that they're trying to gather. Well, what if in addition you wanted to take a look at your city from another vantage point? Well, here's a view shed of Boston from the platform on the Eiffel Tower. This is what you would be able to see. Kind of cool. But what would you do with it, right? It's a good question. I said that this technology exists. We can take infrared pictures of Manhattan, so we can figure out who has their lights on. Where's the energy being used within the city? Kind of cool. Okay, let me come back to privacy. So this was actually a report that was done, I want to say, in the early 80s out of the National Academy of Sciences. And it's pretty true today what's in that report, the issues that surround privacy. But times are changing. And a question is, people actually do voluntarily give their data up in all sorts of ways. Not to the government, right? Not when it comes to health records, but they do voluntarily give their data up in a lot of ways. A lot of our laws, or at least I will speak for the US, again, it's a US-centric view right now, and this time next year I'll give you more of a Canadian-centric view. But in the US, there's different legislation that governs the privacy of information that the federal government collects. But interestingly enough, people can regenerate that data through other sources. And so who's at fault? The government didn't release it. So how valid is some of that legislation? Norms and expectations are changing with generations. And I've had a lot of arguments with people about which way that change is going. For all of the people for the young folks who are using all sorts of social media, are they going to be more amenable to allow us to use their data in different ways? Some people will argue that they will. Others will argue that they won't. So we don't know. Some research needs to be done on this. How are those norms changing, and how will that help us as we address this collision of big data and social and behavioral sciences? There are a lot of technical fixes for multi-level security. It's been around for a long time. Every day this set of research grows, but we don't necessarily take advantage of it. And when you're thinking of the curation and the management of data, I encourage you to think about that, about different access, and I'll point out an interesting data enclave in a second. Again, we don't know what the optimal level of privacy is for the studies that we're going to do. We don't necessarily need to know if your light is on. We just might need to know that your block is consuming a lot of energy and that brownouts are going to have to happen in that region. Let's see. And then the last point I think is really important is that we really need to ensure that things are done sensibly, because one bad mistake in this space will cause years and years and years of slowdown in our work and in the research and what we might be able to accomplish. So one thing that we like to think about when we're trying to think about the privacy space is this resolution or cadence between anonymity and our data volume and resolution. So you can, in this particular cartoon, you can think of things moving from the individual to a block to a whole section of the city. You increase anonymity, but then you're getting a decrease in the data volume and the resolution with which you can study things. So there has to be some sort of a way to look at this and make decisions as to what the right level of anonymity in data volume is for different types of problems. But in this, you can set mathematical models up for this. Much of my historical research, which does seem like historical at this point, was in building such models. Well, there are some good examples where privacy access levels to different types of data across different organizations, curation do occur. And this is an example of what's called the NORC data enclave. And NORC is a think tank in the US, and they've dealt a lot with the federal statistical agencies across the US. And in the US, our federal statistical system is completely decentralized, whereas in Canada it's slightly more centralized. So with this, what they've been able to do is to provide researcher access to all sorts of federal data that's been collected under different types of confidentiality assurances, and to be able to allow for actually using data across the different domains, as well as collaborating. So there's a lot of reinvention. If I'm using some data to study a particular question, and you come along and you've got the same question, it would be nice that you could know what I've done, even if it hasn't appeared yet in a publication. So these sorts of enclaves allow the researchers to begin to collaborate in new ways and to share and access information. And the key is there is full attribution to the researchers, so that if you're going to use my analysis, I am still going to get the credit. And that's really important, and this is one of the topics that you guys have been talking about a lot. Something I don't know as much about, and I think that Chad will talk a little bit about this, is this incredibly exciting project that's multinational, that's going about building tools and collecting data and building repositories. So that's really important. And so I'm going to close now, probably under my time, I hope, with some thoughts. I think that we really need to think about this collision of social sciences and big data. We need to figure out how to engage the community. We need to understand what the government is responsible for. I've thought about this again a lot from a U.S. Viewpoint, and so now it's very exciting to look at how does this play out in the Canadian arena and how does it play out across countries. But the government has a big role here, both from the perspective of the data that they collect to drive government policy, as well as the research agencies that support the collection of information, and the importance that those resources not be wasted and that the information be curated, that we're able to reuse and reproduce research and add to that new research. We also have to start striking partnerships with the government and get them comfortable with the fact that policies are going to be informed by data outside of the government. They cannot circle the wagons and say, no, you can't use that data to make policies. It's happening. And the media picks it up like crazy. So what good is a federal document if no one's going to believe it? So if you could recreate from scratch, from a blank sheet of paper, how we create some of our really important national indices that took into account the tsunami of information, how would we do it? And how would we do it in a way that we believed it and that the public would believe it? Here at Waterloo, we have an incredibly exciting center, and it's the Center for the Canadian Index of Well-Being, which, by the way, was just released 2 days ago. Much conversation around the world. Everyone agrees that GDP doesn't measure what we think it does. Everyone agrees that I don't think people disagree that GDP is a good measure. I think that they agree that it probably is not a good measure, but we don't have anything else. So we have to keep using it. Well, the exciting thing about the Index of Well-Being is that it's now starting to track and show, is this perhaps a better measure of our economy? And how do we begin to use it? That's the partnering that government has to do with the research community and with ways that we collect and data that can be used that has not necessarily been collected in the historical traditional ways. So we need to build alliances, and in particular, we need the private sector to openly participate. When I mentioned to you that Google is using this public data to come up with consumer price indices in certain sectors, how they're doing that, in part, is that if you advertise with Google, they cut a deal with you that if you let them watch your hits and sales data, then they just cut a deal with you. So they're getting all this backroom data. They're running experiments all the time. But that's how they're getting these estimates. How do we get them to openly participate? How do we get the private sector to openly participate? There has to be something in it for them. Otherwise, they're not going to. Transparency and information sharing is critical. I am passionate about data reuse and reproducibility of research. We wouldn't be in the climate change pickle discussion that we're in if we had adopted this philosophy 2 decades ago. It's hard. Your jobs are hard, but we need to get there. And then I think most importantly, from the perspective of privacy, we need to come up with some common good questions that get people comfortable with how the data is collected and how it's used. So with that, I want to thank you, and I want to tell you, do good work. Yes, my first comment is there's just volumes of research mounting in the statistical sciences field to address exactly this question. That how do we use this unstructured data? How do we determine what the representativeness is how do we determine what its representativeness is? So you're right on, you're right on the money to worry about this. How do we move from the way that we structured and the statistical representation, all of the good statistics that's gone into gathering data that's representative of something, to using this unstructured organic data and to figure out what is it representing. So there's a lot of research that's going on, and there are different ways to approach that. The volume of research that's growing up with social networks, gives us ways to understand who is in the network. So it's almost like the inverse problem, is that you begin to understand what is this representing and who am I missing?
But what do we do if we no longer have a representative baseline because Stats Canada made this
Right. So if you no longer have a representative baseline, you're going to have to change the way that you ask the questions, or the questions that you study. We're just going to have to change that, and we also are going to have to learn and to figure out how do we supplement that with other information. So this whole area of information integration and uncertainty quantification, it's all about how do we take heterogeneous information, heterogeneous data, and integrate it to try to answer certain questions with the right representation, as well as then placing the uncertainty about that in terms of that representativeness. So there's a lot of research going on there in ways that we can do that. So so we can use, and a lot of this comes out of what's called hierarchical modeling and Bayesian modeling, the way that we can combine information in different ways. But what's going to be critical is that we need to start to really educate people about uncertainty, because it means that there could be huge levels of uncertainty around that.